Yeah, I'm David Allen. I'm an ophthalmic surgeon working in Sunderland in the United Kingdom. I had the privilege of being one of 4 surgeons who were in an advisory board to Alcon during the development phase of the Centurion vision system. Well, surgeons have heard about active fluidics for 3 or 4 years now, but many surgeons don't really understand what it's about. The development of active fluidics with the Centurion system really has been a paradigm shift in the way that we tackle phacoemulsification. With a gravity system, the inflow of fluid is purely passive. The only thing that influences the inflow is gravity. It's the height of the bottle above the patient's eye that determines the pressure with which the fluid flows into the eye, and the bottle needs to be at a sufficient height to guarantee there is enough inflow back into the eye at the time of peak outflow that might occur during post-occlusion surge. When there isn't post-occlusion surge, that pressure that is generated by gravity in the high bottle is unnecessary. And many surgeons don't really appreciate the pressure that is generated inside the eye. It's much higher than most surgeons, I think, would feel comfortable about their own eye being inflated. Now, with active fluidics, as produced by the Centurion vision system, the fluid is forced into the eye by pressure plates applied to the bag of balanced salt solution, but it's forced into the eye in response to changes in pressure in the eye as measured by the system. There are other systems that do use forced infusion, but what they do is pressurize the infusion of fluid constantly. With active fluidics, as it's implemented in the Centurion system, that pressure change fluctuates continuously because the system is measuring the inflow of fluid, it's measuring the pressure within the eye, and it's making fine adjustments to how much fluid is put in. The difference that active fluidics makes for me as a surgeon is that it gives me a much more stable anterior chamber. With a gravity system, we've already said that the inflow of fluid is dependent on gravity, and it's passive. But then when you go into foot position 2 and generate aspiration, because of the laws of physics, there is a lag in the fluid coming in because of resistance to flow in the inflow tubing. And that means that although you start with a high intraocular pressure when you're in foot position 1 with just inflow, the moment you go into foot position 2 and generate aspiration, the intraocular pressure drops significantly. And then as you ease off in foot position 2 and you have less aspiration, the pressure goes back up. And it's constantly changing as a result of normal aspiration flow during the procedure. And this can be seen in surgery by continuous fluctuations of the anterior chamber depth. You see movement of the iris, and this is quite separate from post-occlusion surge. So with active fluidics, because the system compensates for a pressure drop when you have aspiration, there isn't a pressure drop. The other benefit is that we don't generate a high intraocular pressure at any point during the procedure. Because as I've said, with gravity fluidics, the intraocular pressure is really significantly high for a significant part of the procedure. But with active fluidics, the intraocular pressure remains within about 5% of the target that the surgeon sets on the machine. The Centurion vision system already had significantly better post-occlusion surge response than other machines on the market. Active Sentry now brings an even better post-occlusion surge response, which gives an added layer of safety. With Active Sentry, the pressure sensing is actually in the handpiece. And so there is a significantly shorter period of time before the machine knows that the pressure in the eye has dropped with post-occlusion surge. As a result of this, and some other factors that mitigate surge, the amount of post-occlusion surge, the volume of fluid that is removed during surge, is significantly less than without Active Sentry. and it is for a much shorter period of time as well. So this is just an added layer of safety, particularly when dealing with hard cataracts, where you might get significant numbers of post-occlusion surge events. In addition to this, there is a much better ability to control the intraocular pressure within the eye. Now with Active Sentry, with the pressure sensor being in the handpiece, then by definition the pressure is being measured at the eye level, because the handpiece is at eye level. And so this just takes away one of those other factors that surgeons find difficult to adjust.